Hi, this is Shawn Smith. This is my video project for Physics 3030. I decided to do my project on the CMB, the cosmic microwave background, and the best way to explain what it is to explain where it came from. So to look at where the CMB came from, we need to look at the universe about 380,000 years after the Big Bang. We have this picture here that's a timeline of the universe, and we're looking about right here, and this picture actually shows an image of the CMB. So at this point in the universe was much smaller and much hotter. The temperature was so extreme that any matter that existed as particles. The extreme heat made it so that none of these particles could form into atoms. Not even hydrogen could form. So basically the only thing that existed was this opaque soup of particles floating around and bumping into each other. And within this soup, there were also a huge amount of photons. They were just bouncing around in there with the protons and electrons. The fact that this soup, or plasma, was opaque means that these photons didn't have anywhere to go. Opaque means that light can't shine through, so these particles of light were basically trapped. So what happened was, as the universe expanded, this particle soup began to cool off, and as it cooled off, it began to allow these particles to combine and form atoms, which then allowed for the formation of hydrogen. This basically means that all those photons no longer had anything in their way, and they were free to shoot out through the distance of the known universe. So as things cooled off, the universe went from being opaque to transparent, and it was like billions of flashes going off in all directions. This picture sort of shows the particle soup, the formation of atoms, and the photons escaping. And the most amazing part is, these photons are still around, and they are what make up the CMB. Now, of course, we don't go out and look into the night sky and see these photons glowing, although that would be pretty incredible. You would need some sort of superhero-style microwave vision, because over all this time, these photons have shifted into the microwave band of the electromagnetic spectrum, so they are invisible to us. Here is the anisotropy probe image of the CMB, and this is what is actually surrounding us from our viewpoint here on Earth. And what it shows is variations in temperature, mostly due to interference of the photons we're looking at, things in the way. In reality, the entire CMB maintains 2.7 Kelvin. So that's the CMB. It's basically ancient light radiation from the beginning of the universe, and it's a huge deal because it corroborates the Big Bang. So that's the CMB. That's my video. It's been a good semester. I've learned a lot, and goodbye.